Hello class. So we're working on the Chapter 7 practice exam. I wanted to do this video just in case you were struggling with the lesson or the review. And so we're just going to go ahead and work through these problems. Keep in mind that the problems here are randomized, which means that they're going to be the same problems, but the order is going to be different every time you retry the exam. So just keep that in mind as I'm working through the problems. So my number one will not necessarily be your number one. All right, so let's look at the first question here. It says find the exact value of cosine of 300 degrees. So first thing what you want to do when they're asking you to find the value of a sine or a cosine or tangent is to show your work by drawing, drawing essentially, not necessarily the unit circle, but at least draw the angle. So we have 300 degrees, right? So we know that if we're looking at 300 degrees, that means we have to be in quadrant 4. And the reason is that a full circle is 360 degrees. So that means that I have to do, well, that's almost a full circle minus the 300 degrees that we went, which is 60 degrees. Remember that a positive angle goes counterclockwise, a negative angle goes clockwise. So that means that this angle here has to be 60 degrees. Then we go ahead and draw our reference triangle. And I know that this is going to be x. This is going to be a negative y. This is going to be negative because we're going down, okay? All right, so clearly x is going to be positive because we're in quadrant 4, and y is going to be negative because we're in quadrant 4. And remember that x is the same thing as cosine, and y is the same thing as sine. So in this case, the cosine is going to be positive because x is positive. All right, now also keep in mind that we need to figure out what the cosine is, but we have this reference triangle here to help us. So if that's 60, that means this has to be 30. That's a 30, 60, 90 triangle. Okay, so we have 60, we have 30, we have 90. Now, just since we've done this a few times already, here's I'll show you a couple of shortcuts to do this, okay? We're using the triangles. So since this is the 60-degree side, this is going to be 1. This is the 30-degree side, that's going to be square root of 3. And then this is the hypotenuse, that's going to be 2. Remember the whole a square root of 3, that stuff? Well, a is usually going to be a half, or depending on how you choose it, you can choose it to be 1 in this case, so that you get 1, square root of 3, and 2. If you want, you can just memorize this triangle and use this triangle to help you find cosine of 60 and 30. So in this case, remember cosine is adjacent over hypotenuse. Remember SOHCAHTOA. So adjacent over hypotenuse. Since we're interested in 60 degrees, this has to be adjacent, this has to be hypotenuse. All right, so the cosine of 60 degrees in this example is going to be 1/2, which is the same thing as cosine of 300, which we proved because 60 degrees is the reference angle to 300. And it's going to be positive 1/2. All right, another shortcut. So this is our final answer, by the way. So 1/2 is our answer. But another way that you could do this is using a table. The table method that I showed you, it's really easy to do. You have sine, cosine, and then you have 0, 30, 45, 60, and 90. Remember that all of these have square roots in them. And they all have they're all divided by 2. And then you start for the sine, you start from 0 all the way to 4. And then for the cosine, you do the opposite. You start from 4 and then you end up at 0. And this gives you values of sine and cosine right off the bat. So I know that from this, sine of 0 is square root of 0 over 2. And then we know that square root of 0 is just 0. So this whole thing is 0. So sine of 0 is 0. And then sine of 30 is 1/2, because square root of 1 is just 1. Sine of 45, square root of 2 over 2, and so on. And then the last one, sine of 90, is 2 over 2, which is 1. All right, so this is another quick way of actually finding your answers. So either way, we're going to choose 1/2 because that's our solution there. So let's move on to the next one. We have a triangle, and they want us to determine the ratio for sine and cosine. So let's go ahead and draw the triangle real quick. This is x, y, z. This is going to be 5. I drew the z and the y in the opposite direction, so let me switch those. This is hypotenuse is 12. This is square root of 119. So we know clearly this is the longest side, that's the hypotenuse. Now the adjacent and the opposite side depend on the angle that you're interested in. In this example, they're interested in the angle x, which is this angle right here. So since we're interested in an angle, that means the opposite side is this guy. And the adjacent side is right next to it, which is the 5 side. Okay, so again, adjacent and opposite depend on the angle that you're interested in. Okay. All right, so now we have our adjacent and opposite. Remember, SOHCAHTOA. So sine is opposite over hypotenuse. So that means that we got to do O over H. So sine of x equals O over H. And that's all there is to it. Square root of 119 over 12. And then cosine is adjacent over hypotenuse. So we know that the cosine of x is adjacent, which is 5, over hypotenuse, which is 12. And that's my answer. Okay, it's actually pretty straightforward once you know SOHCAHTOA. All right, so let's go to the next problem. We want to find the amplitude and the equation of the midline given the periodic function. Now notice that this does not look like a cosine or sine, but that's okay. It looks kind of similar, but it's not really because it has these sharp edges, right? But that's not the point. The point is that this function right here, whatever it is, repeats every so often. So it does have a period because it repeats, which is why we call it a periodic function. Just like the heartbeat, the heart, has a certain rhythm to it, right? When it pulses, that's called your pulse rate. So in the same manner, it doesn't matter what the shape looks like. If it repeats, then it's periodic. So so let's go ahead and find the amplitude and the equation. So I'm going to go ahead and actually copy and paste this graph so that we can actually draw on it. Okay, so looking at this graph, to determine the amplitude, to determine the midline, you have to figure out your maximum and your minimum. So I know that that's my maximum. I know that these points are my minimum, right? This one and that one. So this minimum is at -1. This maximum is at 5. So remember, the formula for the midline is y equals maximum plus minimum divided by 2. So in this case, we have 5 plus -1 divided by 2. So 4 divided by 2 is 2. So that means my midline is y equals 2. So I'm going to go ahead and circle that. So this is my midline now, which kind of makes sense. It looks like it's cutting the graph in half. So now we need to find the amplitude. So we got to figure out the difference between the maximum and the midline. The maximum is 5, the midline is 2. So the amplitude here is going to be the maximum minus the midline, which in this case is 5 minus 2, which is 3. All right, so our amplitude is 3, my midline is 2. So we're going to have 3 and y equals 2. All right, so number 4. The graph shows a height as a function of time for a ride on a Ferris wheel. Find the sine equation for the graph. So again, let's go ahead and copy and paste that so that I can actually draw on it. Okay, so this is, you're on a Ferris wheel according to this. So basically you start out at some position here at time t equals 0. So you start at, say, 5 feet. So this looks like 5 feet. And then you go up. So maybe on a Ferris, so this is a Ferris wheel, maybe you're 5 feet high. And then over time you're rotating on the Ferris wheel. So then you start being at time t equals 1 second, you're at 25 feet. And then at time t equals 2 seconds, you're at 45 feet, all the way up here, and then you go back down to 5 feet. So but that's basically what it's saying right here. You're going up, and then you're going down, and then you're going back up. So you're rotating in a circle here based off of this graph. So essentially what we want to do is we want to figure out the equation based off of sine. So we're going to have to figure out, remember that the equation for the sine is y equals a sine c times x, oops, not c, it should be b times x minus c plus d. So remember, we got to find a, b, c, and d. So a is the amplitude. So we need to figure out the midline for this. Now we know that this maxes out at 45 feet based off of the y-axis right here. This is at 5 feet. So we got to figure out the average between 45 and 5. So that's going to be 50 divided by 2, which is 25. Okay, so the midline is at 25, which is right there. That makes sense. And then we figure out the amplitude. What's the distance between 25 and the maximum of 45? That's going to be 45 minus 25, which is 20. So my amplitude is 20. That's my A. So we got 20 for my A. Next, we got to find our D. Well, we know our midline. We said our midline was 25, right? So that right there is actually our D. So we know that as well. So let's put that right here, plus 25. So already we got two constants for the equation. So very simple so far for A and D. So now we got to find B and C. So we're going to figure out, well, when does this function start repeating? Well, we can tell that it starts here and then it repeats until it gets to here, right? And after that point, it'll repeat again. Obviously, it'll just continue like that and then keep going forever like that, right? Assuming that you're still on the ride, it'll keep going in a circle forever, right? So the period is going to be the distance from there to there, which in that case is from 0 to, it's kind of hard to tell here, so let me erase this. It's from 0 to 4, so this is at the 4 mark. So it's from 0 to 4, so the distance is 4 minus 0, which is 4. So my period here is 4. So we have here that t equals 4. So how do we figure out the b for that? Well, remember that the formula for period, and I'll write it off to the side here. So we said that t was 4. Remember that the formula for period is 2 pi over b? So that's what we got to use here. So 4 is the same thing as 4 divided by 1. Then you're going to cross multiply. 2 pi times 1 is 2 pi. 4 times b is 4b. And then we got to solve for b, so we're going to divide by 4. All right, and that's going to be our b. Now 2 over 4, that's just a half, right? That's 1 half. So that's going to be 1/2 pi or pi over 2. So pi over 2 is b. So now we know b. b is pi over 2. All right, we don't have to find x because x is just a variable. We do have to find c. C is the last constant we got to find. The c is the phase shift. Okay, so we got to figure out what the phase shift is here. So remember that the sine graph looks like, starts here at the origin normally and goes like that, right? So we got to make it look like that. The only way that could be the case is if this point here moves here. If that's the case, then everything is going to shift over, and then it'll look like the snake-like graph, right? So it'll have that shape. So how much do we have to move it? Well, according to this, we have to move it to the left by 1. All right, so left by 1 unit from here to there, right? From 1 to 0, that's 1 unit. So then you're going to reverse it, remember, because we don't want the blue graph, we want the black graph, right? So instead of moving to the left 1, I got to reverse it. I move to the right 1. Okay, so that means it's going to be positive. To the right means positive. Okay, so we're actually going to reverse it and say we're going to go to the right 1, which is positive 1. So that means my C is positive 1. Okay, so whatever you do to get from the original to the blue, you reverse it. Okay, so if I'm going left, reverse it, it's going to the right. So C is positive 1, which means that this is going to be 1. C is 1. All right, so this right here is my graph. Now keep in mind that this may not be the actual equation that they give you here. This is a solution of the equation, but it is not the only solution. How do we figure out another solution? Well, the only way to figure out another solution is to pick another point. So instead of picking this first point, I'm going to erase it now. And this time I'm going to choose a different color. I'm going to choose red. Let's go ahead and choose instead this point right here. Actually, let's go ahead and choose, let me go ahead and continue this curve. So this curve continues forever on the left side as well, right? So that means we can pick, there's points here, there's points here, there's points there, and so on. This is going to be at -1, -2, and so on. Okay, so another way of doing this is essentially you take this point, which I will put in red, and I can move that point 1, 2, 3. And that would also work. I can take that point, move it there, and then I get my new curve that looks like that. And that looks like a sine. So that's another solution to this equation. Okay, so there are multiple solutions to this equation. You could even take this point and move it over 5 units, and that will give you another solution. There are multiple solutions to this. So let's go ahead and take the original one, the one where I move in red. So that means that's 3 units to the right, which means it's actually 3 units to the left, okay? Which means it's -3. So that means C is also equal to -3. So let's go ahead and change this to a -3 instead of a -1, because that's not our solution according to, well, that's not our only solution according to the multiple choice. So there's our equation. So which equation does that look like? Well, remember, 2 minuses make a plus. So we have pi over 2 times x is pi over 2x. We're going to distribute. Pi over 2 times 3 is 3 pi over 2. And then plus 25. All right, there's our equation. It actually looks like this one right here. Okay, so sometimes the equation won't be on there for the C that you chose, so you got to pick another C. And that's fine. There's multiple C's that you can choose here until you get the right one. All right, so there's our equation. All right, so let's look at number 5. Find the missing side of the triangle, round your answer to the nearest 10th. Okay, so we're going to go ahead and quickly draw the triangle. Okay, so if we want to figure out this triangle, our angle of interest is this one right here, 61 degrees. So we have here opposite over hypotenuse. This is not adjacent, this is hypotenuse because that's the longest side. So what's opposite over hypotenuse? Well, that is going to be SO in SOHCAHTOA. Sine of 61 degrees is opposite over hypotenuse. Opposite is x, hypotenuse is 95. Then we simply solve that equation. We're going to multiply both sides by 95 so that it cancels. And so x is equal to 95 sine of 61 degrees. All right, now you can go on Desmos or your calculator and actually, so if you go to Desmos, you can type in Desmos scientific calculator right there. And you can actually type 95 sine of 61. Again, use this to check your work for the other problems, but for something like this where you need a decimal, you can use Desmos to definitely do your work here. But notice that I showed my work here. So 95 sine of 61, and then make sure that this is set to degree mode. If you move it, if you click on it, it'll set it to radians. So you want to set it to degrees, 61 degrees. So that's 83.09-ish, okay? So 83.09-ish. And then let's go back here. So they rounded it to the nearest 10th, so it's going to be 83.1. All right. So looking at the next one, find the amplitude and equation of the midline. Let's go ahead and, as usual, let's draw on this. Okay, so again, our maximum here is 5. Not 5, I'm sorry, 3. 3. And then our minimum here is -2, right? That -2 line. So take the average between 3 and -2. So 3 plus -2 divided by 2 is 1/2. That's my midline. Y equals 1/2. So that's over here. And then if this is 1/2, then what's the distance between 1/2 and 3? 1/2 is the same thing as 0.5. So you got to do 3 minus 0.5, and that'll give you the distance. So 3 minus 0.5 is 2.5. That's my amplitude. So the amplitude is that height. So we have our amplitude is 2.5, our midline is a half or 0.5. It doesn't take very long to actually do that problem. So you can breeze through that one. Find the radian measure of 110 degrees. So you got to convert that to radians. So remember that in a half circle, so remember that pi is the same thing as 180 degrees. So you're going to use that conversion factor. Since this is actually in degrees, you want degrees to be on the bottom and you want radians to be on the top. So that means 180 goes on the bottom, pi goes on the top. Degrees cancels, so you get 110 pi over 180. And then you could reduce this by dividing by 10. And that'll give you the final answer of 11 pi over 18. Okay, so that's this one over here. 11 pi over 18. All right, so now for the point 1612, find sine and cosine. So we're just going to graph the point 1612. So this is 16, this is 12. All right, and I drew this just so that you can see that this forms a right triangle, right? So there's that hypotenuse that we were talking about. You can bring this down as a right angle, and now you have your side here is 16 because that's the x component. Remember, when you have a coordinate in space, you travel along the x first, and then you travel along the y, right? This is the x coordinate, and then this is the y coordinate, and the y coordinate is 12 according to the point in space. So that's 16 and 12, and then you can find this using the Pythagorean theorem. We're going to call this C. Okay, so we got a right triangle here. We can use the Pythagorean theorem. So we have a squared plus b squared equals c squared, right? So 16 squared plus 12 squared equals c squared. And then we got to do the math here. So we got 16. We got to do 16 times 16, which is 256. Plus 144 equals c squared. This is going to be 400 equals c squared. Take the square root. And the square root of 400 is 20. Again, you could do that on Desmos. There's a square root function on Desmos that you can use. Do the square root of anything. All right. So we got c is 20. So we got that the hypotenuse is 20. So then we're interested in the angle theta. What's that angle? Well, that angle is the angle to the x-axis right here. That's always going to be, by definition, the angle to the x-axis. So in that case, what's cosine? Well, cosine is adjacent over hypotenuse. And we know the hypotenuse is 20. The adjacent has to be 16 because that's next to the angle. And then this is opposite. All right, so cosine of theta is adjacent, which is x, over hypotenuse, which is 20. So that's my cosine. My sine is opposite, which is 12, over hypotenuse, which is 20. And that's how you do it. So we got 16 over 20 and 12 over 20. All right, sketch the angle 35 degrees in standard position. Remember, standard position means that you start at the initial side, which is the x-axis, and then you travel to the terminal side, which is where it ends, right? And then a positive angle means you're going clockwise or counterclockwise. Negative angle means you're going clockwise, right? So here we have an angle of positive 35 degrees, so we're just going to go 35 degrees counterclockwise, and that's my angle. That's it. So this is 35 degrees. So that's this guy right here. That's going to be C. All right, what is the graph of one cycle of a sine curve with the given characteristics? What is the equation of the sine curve? Okay, so let's do the graph. So in this case, the amplitude is 4, and amplitude is the same thing as A. And they say A was positive, so A is actually positive 4. Period is given by T, and the period is 2 pi. The midline, y equals 0, so that's the midline, which really is our d, right? Midline is our d in the equation. And then our period is 2 pi over b. Remember, that's the formula for the period. So this is 2 pi over 1. cross multiply. So you got 2 pi times b equals 2 pi times 1, which is just 2 pi. The 2 pi's cancel out, leaving you with b equals 1. So b is just 1. A is 4, b is 1, d is 0. And it's not shifted at all, so we can assume that c is 0 as well. Because it doesn't say whether there's any phase shift or not. So we can assume that it's going to be 0 phase shift. So they said, what is the equation of the sine curve? Well, that's going to be a sine of b x minus c plus d. Remember, that's always a generic curve. A is 4, so this is going to be 4 sine, b is 1, x minus c is just 0, and d is 0. So really, you can just ignore this, and you can ignore this, and you can really ignore this. So the equation is just 4 sine of x. All right, so that's my equation. In this case, they use theta instead of x, so we'll just change x to theta. So it's going to be 4 sine of theta, which looks like d. And then that makes this equation makes sense because it's a period of 2 pi from 0 to 2 pi, which they said the period was 2 pi. And the midline is 0, which that makes sense. So the answer is going to be D here. All right, which of the following angles is not coterminal with the other three? So we have 591, negative 129, 51 degrees, and 231 degrees. Okay, so 591 degrees, if we were to graph that, well, how many, it's definitely more than a full circle because a full circle is 360. So how much more than a full circle does it go? Well, let's go ahead and subtract 360 from it. And that gives us an angle of, if I do this correctly, because you got to do a little math here. So 231 degrees. Okay, so 231 degrees. So far, that looks like the same as that. So it cannot be these two. It definitely cannot be those two because those are coterminal. Coterminal means that they're really the same angle. So if you were to graph that, that's going to be, this is 180, right? Remember, this is 180 right here. From here to there is 180. And then an extra amount to get to 231. How much of an extra amount? Well, the extra amount is 231 minus 180. So in that case, 231 minus 180 is 51 degrees. So that's this angle right here is 51 degrees. That little tiny angle is 51. Okay, so that's 231 degrees. Now notice that 51 degrees is this angle right here, this tiny angle. This does not mean that that's the answer. This is not coterminal because this angle, 51 degrees, is only from here to here, right? This is 51 degrees if you were to graph it. So that is definitely not coterminal. So, and negative 129 is actually this angle right here. That's negative 129. So how did I get that? Because 180 minus 51 is 129. So if you were to do 180 minus the 51 that we just found, that gives you 129, which is the same thing as that. So these three in red that I crossed out are coterminal. They're the same angle, whereas 51 degrees is not the same angle. It's in quadrant 1, whereas the other ones are in quadrant 3. So this is the final answer, 51 degrees. All right, so number 12, a reference angle is 36 degrees, and its terminal side lies in quadrant 2. So we know that the angle is in quadrant 2. This is quadrant 2 here. And the reference angle is 36 degrees. So there's my guy right there. What is a positive measure and negative angle measure? So the positive angle measure will be this one right here. And the negative angle measure will be this one right here. So let's do the red first. The red, we know that this right here is 180. So 180 minus 36 is going to give me this guy. 180 minus 36. Which is going to be 144. So 144 degrees is my positive angle. Now let's look at our negative angle. So we know that this from here to here is 180, negative 180, right? So this is negative 180 because I'm clockwise is negative. And then I have to go an extra 36 degrees, right? So that means I got to add 36 degrees to it. So it's going to be 180 plus 36, which is 216 degrees. But remember, we're traveling clockwise, so it's going to be a negative angle. So this is my negative angle right here, and then we got our positive. So negative 216, positive 144. All right, so find the measure of an angle between 0 and 360 that is coterminal with negative 271 degrees. So negative means going clockwise. So that means it's going here, that's 90 degrees, that's 180, that's 270, and then an extra degree right there. So this right here is negative 271 degrees. All right, so then if I want to find the angle that is coterminal to that, well, that's just going to be this angle right here. That angle right there is coterminal. It gives you the exact same position for a smaller angle. So what is that angle? Well, this makes almost a full circle. So this is going to be 360 minus the 271, which oh, I'm sorry, it's going to be, hold on a second right here. Yeah, which in that case is going to be 89 degrees. There you go. I almost did faulty math in my head there. So yeah, this is 89 degrees. So that's your angle right there, positive 89 degrees. And it's positive because you're going counterclockwise. So there it is. And that angle is between 0 and 360. So we're good. All right, so for the point 4, negative 3, find tangent. So again, 4, negative 3, 1, 2, 3, 4. Negative 3 is down here. So we'll look at this coordinate right there. We're going to draw a radius there. That's 4, negative 3. And so we're going to draw a right triangle from that, like this. Okay. So this is my positive x side. This is 4. This is my 4 side right here. This is worth 4. And this right here is worth negative 3 because you're going down 3. Okay, so if we want to figure out tangent, and this angle right here to the x-axis is my theta. So then remember, using this triangle, well, this is my hypotenuse. Opposite is directly across theta. So this is opposite. And this guy next to it is adjacent. And tangent, remember TOA. Remember SOHCAHTOA, opposite over adjacent. So tangent is opposite over adjacent. Opposite is negative 3. Adjacent is 4. So my angle here, or my tangent, is just negative 3 over 4. That's all there is to it. All right, so we got our triangle here. Another triangle, z, x, y, 15. This time we want to figure out tangent of x and cosine of z. So tangent of x, that's the angle that we're interested there. So what? So remember, tan is opposite over adjacent. The opposite to this angle is that angle right there, which is 15. Adjacent to that angle is next to it, which is this angle right here. So this is adjacent when we're talking about x. When we're talking about x, the adjacent is that side. So we got to use Pythagorean theorem to get that, right? So let me go ahead and draw the triangle again so we can see that. So that's A, that's B, this is C, and we know that C is 25 because they told us that. Okay. So we have a squared plus b squared. B is 15. C squared is 25 squared. So we have a squared plus 225 equals 625. Then we got to subtract that over. Minus 225 on both sides. And that'll give us 400. And then a is 20. I think we already did this one already. I want to say that we did it. So square root of 400 is 20. So this is just 20. Okay, so we know that this adjacent side is 20. So it's opposite, so 15 over 20. Okay, so we got our tangent of x. Now we want to get our tangent of z, right? Or no, cosine of z. Cosine of z. Okay, so we're not interested in this angle anymore. So I'm not gonna call that a anymore. All right. So we're interested in z, this angle right here. So that means directly across from it, this is now going to be opposite, not adjacent, because it's dependent on angle z. And angle z is directly opposite to that side. So that's opposite. Adjacent now is 15, because adjacent is right next to that. And obviously, this is always going to be the hypotenuse no matter what. So cosine, remember from ka toa. So I wrote it down. Where did I write it? So ka, so adjacent over hypotenuse. So adjacent over hypotenuse. The adjacent now is 15. So we have 15 over hypotenuse, which is 25. 15 over 25. All right, so 15 over 20 and 15 over 25. Right here. Okay, so be careful with what angle they're asking you for. Tangent x, tangent z, y. You know, you got to be careful what they're asking for. Okay, so the screen below shows the graph of a recorded wave on an oscilloscope. What are the period and the amplitude? Okay, so we're going to figure out the period and the amplitude. So again, let's copy that graph. All right, so they're interested in period and amplitude. So again, the maximum here is about 4.5, 4.5. The minimum here is about negative 4.5. So if you average 4.5 and negative 4.5, that's going to give you right here 0. So that's my midline. So that means my amplitude is the distance from 0 to 4.5, which is just 4.5. So my amplitude is 4.5. That's that distance there. And then the period is the distance from one wave to another. So let's, instead of doing that one, we could choose that one as the period, but let's do the easier one. From here to here. After this point, it starts repeating, right? So that's one full period. So what's the distance between 0 and this right here is 0.05. So 0.05 minus 0, that distance right there is 0.05. So my period is just 0.05. So that's my period. And that's all they're looking for, 0.05 and amplitude of 4.5. All right, so here they're looking for the missing side. So that's x, that's 32, that's 12. So again, according to this this angle of 32 degrees, that's the angle we're interested in. Then according to that, well, this is adjacent next to it, and this is hypotenuse. And then this is obviously opposite, but we don't care about opposite here. So we only have adjacent and hypotenuse. That sounds like a cosine to me, right? So ka toa, adjacent and hypotenuse. So we're interested in the cosine of that angle, and that angle is 32 degrees. Equals adjacent over hypotenuse, so 12 over x. Hypotenuse is x. There you go. Now we got to solve that equation. So let's go ahead and move the x over to the other side by multiplying it. So now we're left with x cosine of 32 equals 12. Then we'll simply divide by cosine of 32 on both sides. Cosine of 32 is just a number, by the way. So we got x equals that, 12 divided by cosine of 32. So we just got to do that on the calculator. Let's go ahead and do that on decimals real quick. So we have 12 divided by cosine, and then just type in 32 degrees in parentheses, and make sure it's in degree mode. So that's it, 14.15. So 14.2 is my answer right here. We're rounding it to the nearest 10. All right, we got another missing angle problem. So let's go ahead and draw that out. So x, 8.9, and our special angle the angle that we're interested in is 55 degrees. So this is clearly adjacent next to it, right? This is clearly hypotenuse, the longest side. And then this is directly opposite of that, so that's opposite. So here we have opposite over adjacent. So that's TOA, opposite over adjacent. So we have tangent of 55 degrees equals opposite over adjacent. Adjacent is x, opposite is 8.9. Then we got to solve that. So we're going to multiply by x to move it over. Then we got to divide off by the tan 55. Tan of 55 is just a number. It's actually some kind of weird decimal. And that's my x. X is equal to 8.9 over 10 of tan of 55. But of course, we're going to calculate that. So we'll do that on Desmos. 8.9 divided by tan of 55. 6.23. So we got 6.2 centimeters. That's all there is to it. All right, so here they're interested in finding the measure of the angle. So here they give you that this is 65 degrees, and they want to figure out this angle right here. All right, well, that angle is actually easy to find because we know that from here to here is 180. So then that means we got to do 180 minus 65. And that will give us the angle. You can also do 90 plus 65, and that would also work because you're going 90 degrees and then an extra 65. So you can also do that, or you can do 180 minus 65. And that'll be, either way, you'll get the same answer. You get 155 degrees. Oh, wait, hold on. You should get the same, hold on. This is going to be 90, 65. Yeah, so 180 minus 65 is 105. Does that make sense? Let me double check that real quick. Oh, yeah, that doesn't make sense. I'm sorry. It's not 180 minus 65. That doesn't make sense. Because, okay, so we know that this is 180, right, from here to here, but they give us this part, so it doesn't make sense to do 180 minus 65. So, well, we know that if this is 65 right here, then this has to be 90 minus 65, because this makes a right angle, and so this right here is 35 degrees, and then you could do 180 minus 35, which is 155. But again, now that I think about it, the easiest way is just to do from here to here is 90, and then 90 plus 65 is going to be 155. So that's going to be probably the best way of doing this kind of problem. All right, so 155 degrees is my final answer. All right, we're finished. We're trying to wrap up here. Number 20, let's graph the function in the interval from 0 to 2 pi. So we have y equals sine of theta plus 2 minus 5. So remember that the sine looks like this, right? Remember that what the plus 2 does. The plus 2 is essentially my phase shift, right? So remember that the function was a sine b x minus c plus d. Well, the d is minus 5, which means this is shifted down minus 5. So 1, 2, 3, 4, 5. This should actually be shifted down here, right? So that's why it's down. That's why it's minus 5, because it's all the way down. And then the plus 2, if you compare these two, plus 2 is equivalent to minus c. So 2 is equal to negative c. And that tells us that c has to be negative, right? Because if I move the negative over there, then that's going to be negative 2. So c is negative 2, which means this is shifted over to the left. So we got to take this curve, which we shifted down already by minus 5, and we got to shift it to the left by 2 units. So 2 units, it's going to, so if I shift it over 2 units, it's going to be 1 and then 2-ish right here. It's around there. It's not exact. So then if I shift that over 2 units, then this hill right here is going to approximately be here. Here, let me bring this up. And then this part is going to be shifted too, so it's going to be somewhere around here. Again, this is just an approximation. And so we have something that kind of looks like that. And then we're going to see which one that matches up with. So according to this graph, looking at the first one, it is shifted down to minus 5. So that's good. 1, 2, 3, 4. This should be 4 right here, and then this right here, the midline is minus 5. Okay, and then down here is minus 6. So yeah, it shifted down to the minus 5. So that means the maximum is at minus 4, but the midline is at minus 5. This looks like this one right here. If you continue it, it looks like that graph. So we're going to choose A. All right, an angle theta has a measure of 150 degrees and a terminal side xy. What are the values of xy? So this is on a unit circle. So we have a unit circle, That's not a very good graph, so let's try it again. So we got a unit circle, and it's at 100. So this angle is at 150 degrees. So that means it's right over here. And this is my coordinate xy. Remember that on a unit circle, this is a unit circle now. On the unit circle, the x stands for the cosine of the angle, and the y is the sine of the angle on a unit circle. And if we know that this is 150 degrees, well, that means that this is 30 degrees. So we can draw a reference triangle that looks like that. So if that's 30, this is 60. Remember the shortcut that I showed you, that if this is 30, this is square root of 3. 3 goes with 3. And then if that's 60, that's going to be 1. And then the hypotenuse is always going to be 2. And then you can use your angles from this. So in this example, we're looking for x and y. So x is cosine. In this case, the x is going to be negative. The x is going to be negative, and the y is going to be positive because we're in the left side of the graph. So in quadrant 2, x is negative and y is positive. All right, so that means that we have x is going to be negative, and x is cosine. So what's a cosine? Cosine of 30 is adjacent. That's adjacent over hypotenuse. And that's hypotenuse. So it's going to be square root of 3 over 2. But since x is negative, we're just going to make a negative here. All right, so x is negative square root of 3 over 2. And then y is positive, and it's going to be sine. So what's sine of 30? Sine of 30 is opposite over hypotenuse. So it's going to be 1 over 2. And that's my y. Okay, so we got y is 1/2, x is negative square root of 3 over 2. Okay. So number 22, we have a wave with a function y equals negative sine of 5x. There's an invisible -1 here, which I will not write. The amplitude and the period of the function. So remember, the function is a sine b x minus c plus d. So the a is that guy right there. So the a is -1. But remember, the amplitude is the absolute value of a. So if a is negative, amplitude has to be positive, no matter what. The amplitude is always going to be positive. So even if a is negative, the amplitude is going to be positive. So positive 1. And then according to this, you could tell that b is 5. And you could tell that there is no c, you can tell. And you can tell that there is no d. d is just 0, and c is 0. Okay, so amplitude is clearly 1. Now b is clearly 5. So we're going to find the period, 2 pi over b. It's technically the absolute value of b. So if b were to be negative here, you just make it positive. So it's going to be 2 pi over 5. So that's my period, using that formula. 2 pi over 5, amplitude is 1. Be careful, because sometimes they might say amplitude is -1, and it's never going to be negative. It's always going to be positive for the amplitude. Find the exact value of cosine of 3 pi over 4. So cosine of 3 pi over 4. So we got to convert that. If you're not comfortable with radians, then I would convert it to degrees. So let's do that right away. So you're going to have to show this step right here. So remember, this is in rads. So that means rads has to be in the bottom. Degrees has to be on top. So we have pi rads is the same thing as 180 degrees. Rads cancels. 180 divided by 4 is 45 degrees. And then 45 times 3 is 135 degrees. So that's my angle. Well, that's not my answer. That's just my angle. So we're looking for cosine of 135 degrees. All right. So then I know then that has to be on this quadrant right here, because that's 135 degrees. And then that means this has to be 45 degrees, because 180 minus 45, or minus 135. So 180 minus 135 is 45. And then I know that this is going to be a right triangle. So we got our reference triangle here, 45. And that has to be, so this is a 45, 45, 90 triangle. which means, so I'll show you the shortcut for the 45, 45, 90. It's going to be 1, 1, square root of 2. So that's my shortcut for the 45, 45, 90. So if we want to do cosine, cosine is adjacent over hypotenuse. So cosine of 45 degrees is 1 over square root of 2, adjacent over hypotenuse. So, and then of course we're going to rationalize that. So we're going to multiply to get rid of the radical in the denominator, you got to multiply by the same radical. So 1 times square root of 2 is square root of 2. Square root of 2 times square root of 2 is square root of 4. But square root of 4 is 2. So it's going to be square root of 2 over 2. Be careful. Here, sine, the x coordinate is negative here, and the y coordinate is positive because you're in quadrant 2. The other way to think about this is all students take calculus. All students take calculus. So since you're in quadrant 2, only sine is going to be positive here, which means the rest have to be negative. Anything other than sine is going to be negative. So tan and cosine are negative. Or you can think of it as x is cosine and x is negative, so therefore cosine has to be negative. So either one of those works. So this answer for cosine of 135 is going to be negative, the answer that we got. So it's going to be negative square root of 2 over 2. So let's go ahead and choose that. All right, we're working up to the end. So we have 24, for number 24, we have an angle, a reference angle of 55 degrees, and they want us to figure out this angle right here. So that's going to be straightforward. It's just going to be 180 plus a little bit of extra. Remember that this is 180. So it's 180 plus a little bit of extra. So it's going to be 235 degrees. And that is it for that one. Okay, so let's go ahead and choose that one. And then the final question, what is the Pythagorean identity to find sine below? So what is sine of theta if cosine of theta equals 5 over 13? So cosine is 5 over 13. This is 7.3 part 2. Theta is in quadrant 4. Remember, all students take calculus. All students take calculus. So this is quadrant 4. So quadrant 4, only cosine is positive. That means that sine has to be negative. So when I'm looking for sine, which is what they want, we're going to put a negative in front of that. And in the formula for the Pythagorean identity, remember it's always going to be the same formula. It's 1 minus cosine squared. So we got 1 negative square root 1 minus, and then we plug it in. Cosine is 5 over 13. So we just got to plug that in there. Don't forget to square it. Sometimes some of you guys always forget to square the 5 over 13. So when you square it, it's going to be 1 minus 5 squared is 25. 13 squared, 13 times 13, 169. And then remember, get a common denominator. This is a denominator of 1. So you need it to be a common denominator of 169. So multiply by 169 top and bottom. That gives you 169 over 169 for the first number, minus 25 over 169. So now you got to subtract the two fractions, 169 minus 25. That's going to be, don't forget the negative there. This is going to be 144. And then take the square root of that. Square root of 144 is 12. Square root of 169 is 13. Of course, you could have gotten this answer using right triangles and stuff like that in SOHCAHTOA, but they wanted you to use Pythagorean identity. So in this case, we got negative 12 over 13. All right, guys, that is it for the problems. I know this was a long video, but this was 25 problems, and I wanted to cover it in sufficient detail. So as usual, guys, I will see you guys in the next one.